University Malaysia Kelantan, UMK, is an entrepreneurial university. We implement the government's aspiration to ensure the younger generations are not only highly educated but also entrepreneurial. UMK is the #1 entrepreneurial university in Malaysia and aspires to be one of the world's best by 2030. This is in line with the National Entrepreneurship Policy, which aims to make Malaysia an entrepreneurial country by 2030. According to this vision, UMK ensures the whole university functions within an entrepreneurial ecosystem. This ecosystem comprises of 9 faculties supported by institutes and centers of excellence implemented with the discipline of innovation-based entrepreneurship. The university's upper management, together with UMK employees at all levels, are committed to realizing UMK as a Malaysian public university well respected for its foundation of entrepreneurship. Implementing this ecosystem, the UMK Entrepreneurship Institute UMKEI oversees 3 other entrepreneurship-based centers: the Center for Entrepreneurship Development and Education CEED, the Institute of Small and Medium Enterprises ISME, and the Global Entrepreneurship Research and Innovation Center GERIC. The Faculty of Entrepreneurship and Business, spearheading this structure, has successfully developed collaborative entrepreneurial networks such as UMK Frontier Street, Entrepreneurship Advisory Council, and proudly led the Committee for Ministry of Higher Education Guide to Entrepreneurship Integrated Education. From the academic aspect, UMK offers 29 undergraduate programs and 16 postgraduate programs in the fields of business and management, tourism and hospitality, science and technology, as well as arts and heritage. The university is constantly enhancing its teaching and learning system to ensure that the process of learning takes place creatively and innovatively through My Academic Integrated System, My ICE, massive open online courses, MOOCs, and blended learning. UMK is committed to the development of first-class graduates to become the leaders of industry. Collaboration with world-class local corporate sectors, as well as a network of well-known regional educational institutions, is aimed at empowering UMK from various angles. This is evidenced by the increase in the marketability of graduates and graduates who create jobs through businesses. Research, innovation, and commercialization is another important part of UMK. Research funding and the number of innovations and commercialized products increase every year. UMK has performed well in various prestigious competitions. With the hashtag UMK for Society, UMK is also involved in various community activities. Our staff and students consistently demonstrate outstanding skills and abilities. With such a great spirit of teamwork, UMK has never looked back to emerge as a respected educational entity in the region. We at UMK believe that our presence will give a new look to the development of the Valley of Knowledge. Indeed, our core, entrepreneurship, will always make us, University Malaysia Kelantan, relevant, unique, and different.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and good morning. Prof. Dr. Razli Cik Razak, Vice Chancellor, University Malaysia Kelantan. Professor Technologist Dr. Arham Abdullah, Deputy Vice Chancellor, Research and Innovation, University Malaysia Kelantan. Prof. Jason Potts, Distinguished Professor of Economics at RMIT University and Co-Director of the Blockchain Innovation Hub at RMIT, all directors, dean and deputy dean, members of organizing committee, and to all our virtual conference participants. Let me begin by giving you a warm welcome to the second day of the 10th International Conference of Entrepreneurship, Business and Technology, INSEP 2022. Ladies and gentlemen, INSEP 22 is the third virtual international conference organized by the Faculty of Entrepreneurship and Business, University Malaysia Kelantan. And for your information, the presentation for this conference features both synchronized and asynchronized, which includes 124 paper presentations. The session were held in several parallel sessions, depends on the field, starting by yesterday. Please refer to the provided e-book book for the details. And all participants must fill out the attendance form per the link pinned on the Facebook. Ladies and gentlemen, we shall now proceed to our next agenda, which is keynote session by Prof. Jason Potts, Distinguished Professor of Economics at RMIT University and Co-Director of the Blockchain Innovation Hub at RMIT. For that, I will hand over the floor to technologist Dr. Alina, Senior Lecturer from Department of Data Science, University Malaysia Kelantan, to chair this keynote session. Please welcome.
Assalamualaikum and good morning everyone. I'm Dr. Nur Alina, your moderator for this session. Welcome to second day of the 10th International Conference on Entrepreneurship, Business and Technology INSEP 2022. Okay, I would now like to introduce our speaker, Prof. Jason Potts, a distinguished Prof of Economics at RMIT University and also a co-director of the Blockchain Innovation Hub at RMIT. For your information, Prof. Jason also a chief investigator at ARC Center of Excellence for the Automated Decision Making and Society. To the audience, please feel free to type should you have any questions or any further explanation from Prof. Jason later. Prof. Jason, now I pass the session to you.
Brilliant. Thank you very much for that kind and welcoming introduction. So what I'm going to be talking about, it's an honor to be here. I should start by saying that it's an honor to be invited here just to speak around what is really my area of expertise and research around digital innovation, digital entrepreneurship, and the growth of the digital economy. So what I want to talk about over the next half hour or so is to introduce you to some of the ways in which my own research team has been thinking about the digital economy and its evolution, particularly towards blockchain. And I want to talk about how I believe this will affect entrepreneurship and the types of sort of courses and development of business schools going into the future in this space. So again, thank you very much for inviting me. If you want to reach out to me, email me, please follow me on Twitter or LinkedIn. All of the details are provided on that. So if we move on to the next slide, please. So what I want to talk about is the idea that we're living through a profound economic revolution right now. And we have been for at least a decade or so at the moment. And that this profound economic revolution is similar to the transition that occurred several hundred years ago with the transition from agricultural or almost medieval economies into industrial economies that happened first in Europe and then spread to the rest of the world with the Industrial Revolution. what is happening is that right now we are going through the same process again, but this time as transition from industrial economies to digital economies. And I want to talk a little bit about what the nature of that transition is and what it then means for business schools and the like. So what we mean by this, this idea of a revolutionary transition from an industrial economy, which I will define, to a digital economy, which I will define, is the theme of my talk here this morning. So if we can move on to the next slide, please. And I'll try and define what we mean by this. So I want to suggest that what we mean by an industrial age into a digital age is not actually straightforward. We've been living in digital economies for at least 50 years now. And what I really mean by a digital economy is the second phase of a digital revolution. So the first phase of the transition from an industrial era economy to the digital age really came with computers. And we've had computers for many, many decades now, really since the 1960s and 70s. We've had the internet as a commercial operation since the 1990s. And the first digital age was largely driven by dramatic falls in the cost of computation. We think of this as the cost of computer chips, of computer hardware, such as desktop computers and laptops and all those sorts of machines. But that first profound digital transformation was a fall in the cost of communication. And that dramatic shift in the cost of communication, we've all experienced that as just the internet making communication very cheap, whether it's sending emails or whether it was Skype and then, other types of, voice-to-voice communication. But essentially, the first digital age was the profound economic revolution that was driven by a fall in the costs of communication, right? Sending messages. And we're significantly deep into that period of the revolution. But that's not what I mean by the transformation to a digital age. What I really want to emphasize is that this profound economic transition from an industrial economy to a digital economy doesn't come just with communication. It comes with this process of digital economic infrastructure, which is digital money and digital digital contracting and other aspects of this. So I want to call that the second digital age. We can think of it as this process of the transition from Web 1 to Web 2 to Web 3, which I'll talk about a bit more soon. But the economic revolution that we're going through now isn't computers per se. It's computers being used fundamentally in the economy in a very, very deep institutional way. And that's what I want to discuss and what we mean by that. So we're 50 years deep into having computers, but we're really only just entering into this area of a digital economy. So if we can move to the next slide, please. Now, let me provide a visual sort of metaphor for what I mean by this. So an industrial economy has industries. It's made of parts of the economy, sectors or industries that you can think of as being basically like vertical stacks. So you've got the agricultural industry or the manufacturing industry or healthcare industry or the tourism industry. And each of those industries forms a part of the economy that is a relatively self-contained industrial sector. But and we'll have individual firms will be part of that sector, and we'll have economic growth that is coming from those sectors, and we measure the economy in terms of those sectors or those industry verticals. And then underneath that, you have all of the economic infrastructure, the provision of money, the provision of identity, legal systems, regulatory systems, public voting systems and democracy, or other types of economic administration that's provided by government. Really sits below that as a public infrastructure that's provided at the level of a nation state, whether it's Malaysia or whether it's Australia or any other sort of nation state tends to provide that economic infrastructure, and industries and the economy sits on top of all of those things. So that's the architecture of an industrial economy. is that structure of industry verticals then sitting on a foundation of economic infrastructure. And we've had that model for hundreds of years now. That is the beginnings of an industrial economy really began not just with the development of new industries such as iron or steel or computers or oil or tourism or agriculture or whatever, but it was the building of that on top of economic infrastructure that was provided by the public sector. Providing, and often you identify these with individual public ministries that are associated with, the Ministry of Agriculture or the Ministry of Health or the Ministry for Manufacturing, and each industry vertical will have its own government ministry responsible for that. So that's the architecture on the diagram on the left of how we think of the architecture of an industrial economy. The transition to a digital economy, the diagram on the right, is the transition we're heading into now. And the way to think about that transition is a digital economy has a different type of architecture for the entire economy, where instead of thinking of it as a number of industry verticals with infrastructure then provided collectively at the bottom, the entire economy is a series of basically infrastructure and application stacks. So if you come from a computer science background or an IT background, you'll be aware of the idea of a full stack developer or a full stack system, where you have a series of sort of software protocols and layers that are developed into a full stack that then provides the entire software project. A digital economy has the same sort of logic, where the base layer of it, we have a sort of consensus protocol layer, which takes care of basic record keeping. That's something like blockchain. Then we have a security layer of cybersecurity, which takes care of verifying the truth of information. And we have an infrastructure layer, which moves things around. Then we have a governance layer for making collective decisions. Then we have the service layer, which is all the individual apps and so on. And that, I want to just present this idea of this shift from an industrial economy being made of industries with common public infrastructure to a digital economy, which is this evolving stack of composable parts of economic infrastructure, is the way to think about the nature of this transition from an industrial economy to a digital economy, that we are just very much in the early stages of this transition. So a new type of economy becomes a digital economy is a new type of economy that has a different overall architecture from an industrial economy. And the most obvious way to make that distinction is that a digital economy is not made of industries. It is instead made of layers of economic economic infrastructure and various other apps that stack themselves up and down. All right, so that's that sort of first mental model. If we can shift to the next slide, please. All right, so what's been causing this? So my argument is that we're entering into a radical a radical shift toward a digital economy, and that is happening rapidly at the moment. We're about 10 years deep into this process. It'll probably be another 10 years for it to play out. So this is a 2-decade process of the emergence of a digital economy. But what's causing the arrival of that digital economy is not just one technology. It's not just computers. It's actually a supercluster of digital technologies of business automation. And this is why we distinguish between that first wave of the first digital wave, which was just communication, from the second wave of a digital economy, which is fundamentally about this stack of digital technologies of digital business automation. So one of those, the one I do a lot of work on, is crypto. So this is new types of digital money and blockchain, which are distributed ledgers. And I'll talk more. I'll go into more detail about what I mean by that. But this also includes AI and machine learning, which is basically distributed and pooled learning, enabling machines to use large amounts of data to make decisions about things and to automate a bunch of processes, whether it's converting data into text or text into images or images into images. But if we think of blockchain as distributed ledgers, machine learning is really distributed computing and distributed learning. Then we have cloud, which is distributed computing. So this is things like Amazon Web Services and Microsoft and so on that are providing compute services that, instead of having them on your own local devices, are distributed on other machines. So we now have distributed computing. Internet of Things, which is the way in which we provide a bridge between the physical world and the digital world, which is effectively large numbers of sensors that can read the state of temperature or whether there's people in a room, or other sort of ways of a physical object, whether it's a car or a room or a bridge or anything physical in the world, being able to connect directly to the internet and have that sort of direct physical connection. So Internet of Things technology is basically sensing technology, which is significant because it provides the physical to digital bridge. We know that also as what are called oracles in the blockchain space. Then we have a set of technologies associated with augmented reality and virtual reality, sometimes called metaverse, sometimes called just gaming. But this is a way of creating a way for many people, whether tens or hundreds or eventually thousands, and then eventually millions of people, to be able to interact in digital environments. And again, in a distributed way. So it's not a centralized, everyone in the same room or everyone using the same computer, but a series of different computers all interacting in the same digital environment. So blockchain, distributed ledgers, machine learning, distributed learning, cloud, distributed computing, Internet of Things, physical digital bridges, metaverse or virtual reality is distributed interaction in a digital world. And the other part of that tech puzzle is the ability for this just to happen very, very quickly, which is all of the super fast or low latency computing. So that's 5G at the moment, or eventually 6G. This is also the acceleration of computing technologies themselves, whether into quantum chips and other types of quantum computing. So those 6 different technological trajectories, blockchain, machine learning, cloud, IoT, virtual reality, and 5G/quantum technologies, are just different aspects of the same supercluster of digital technologies that have all, some of them have been around for quite a long time, but they've all, in the last 5 years, 10 years, they've all started to get very, very good, and they've started to interact with each other. And we're starting to see these technologies come together, which is why I'm referring to them as a supercluster rather than a series of individual technologies. But that supercluster of technologies is the innovation driver that is pushing us into a digital economy. And what that supercluster of technologies is doing is it's moving well beyond the first wave of digital innovation, which was communication. So the first 50 years of computing was largely just better ways of communicating. And email is the classic example of that. But then we got things like Twitter and other ways of communicating. But those communication technologies, what they didn't provide was business technologies. They were ways for people to communicate, but they weren't ways to build new businesses and to create new types of business automation. This new supercluster of technologies, blockchain, machine learning, cloud, IoT, metaverse, 5G, quantum, as it arrives, that stack, that supercluster of technologies as the second wave of digital automation. And what that brings us is like this is the revolution that we're going through. So that's what's driving all of this emergence of digital technology. So next slide, please. So within that tech stack, within that supercluster of technologies, I think my argument is that one of the most important technology there is blockchain. And the reason that blockchain is so significant is that it's the base layer technology that is keeping track of all of the other information. So the way to think about blockchain technology or cryptocurrencies is it's not just digital money, it's not just Bitcoin, it's not just a new type of digital money. That's one use case. The fundamental way to think about the significance of blockchain technologies is that it's an institutional technology for keeping track of all of the information and record keeping and registries and ownership and identity and contracts and payments and other aspects that were previously provided by government ledgers or government registries or banks or other types of base layer and institutional infrastructure. And if we remember back to the slide early on in this talk, where we had an industrial economy as a series of industries, industry verticals, with at the base layer of that government registries or government infrastructure. What a digital economy is doing, what blockchain does, is it takes all of that money, contracting, registries of ownership, identity, payments layers, all of the infrastructure for keeping track of just social facts in an economy, and enables those to be fully digitized. And that's the fundamental shift that blockchain technology brings. And that's a significant step beyond using computers and the internet as a pure communications technology. What this enables is blockchain technologies to be a way of keeping track of facts about who owns this thing, who owns this coin, who has this money, who has the rights to make particular payments. So that base layer of economic infrastructure that is providing facts about how an economy's state is being updated. That's what blockchain does. So one way of describing blockchains that for those from a computer science or technical background is that a blockchain is what's called a state machine. And a state machine is something that keeps track of state, which is the current register of facts or data in a system. And every time something changes, it updates that state. That idea of having, which is also the same thing that economic infrastructure provides around state of ownership, state of payments being made, state of other aspects of an economy. So if we think of blockchain technology as a digital version of all of the administrative record keeping that is needed to sit underneath an economy to keep track of all of the people, all of the machines, all of the ownership, all of the payments, all of the changes in any of that has been made, which is common knowledge about economic facts. That way of understanding the nature of blockchain technology as providing that base layer of an economy upon which everything else digital gets built. So when I described a digital economy before as having as a digital stack of administration and security and communication and so on, all the way up and down, that's what blockchains provide. And then on top of that, we can then build other digital things such as communication between humans and machines. That's IoT. We can have communication between, we can have ways for people to store information and have others accessing that. That's cloud. Then we can have ways of bringing automation or automated decision making into a system. That's machine learning. Then and so on. So this idea of blockchain technology as the base layer of economic infrastructure is why this is significant. This is why we're dealing with a digital revolution at this stage. And this is why blockchain technology is the base layer technology of this supercluster of technologies that is marking this transition to a digital economy. Next slide, please. All right, so that's the sort of nature of the shift. Why is this important? The basic reason that this shift to a full stack digital economy, where the economy is digital all the way down, right to the base layer of record keeping, The reason that is significant is that digital versions of this are much, much cheaper than analog versions or versions that are done by human record keeping or other sort of things. So that basic argument around why is this supercluster of digital technologies, why is this significant? Why will this drive economic growth? Has a very, very simple answer. It lowers costs, and specifically it lowers transaction costs. So we think of transactions, we think of all the costs in an economy as really two sorts of costs. There's costs of production. This is costs of making things, the costs of factories, the cost of equipment, the cost of resources, electricity, coal, shipping, whatever. And then there's costs of keeping track of information. And these are transactions costs. So in an industrial economy, we had huge amounts of innovation in driving production costs down with better technologies. But we had very, very few amounts of innovation in driving transactions costs down because the way in which we dealt with money or record keeping or administration in the 2010s was more or less the same as we were doing it 100 years ago. There wasn't a great deal of advance or innovation in new technologies in keeping track of social facts. But that is what is changing with a digital economy. So we can think of this as reducing search costs. How do I find who owns something, or how do I find information about something? We can think of it as replication costs of producing new versions of information. We can think of it as transportation costs of moving information around. We can think of it as tracking costs of keeping track of how information is moving through a system. And we can think of it as verification costs, which are just verifying and proving that something is true. Now, all of those transactions costs in an economy are significant amounts of costs that need to be incurred in any business. This is the costs of accountants and lawyers and the costs of government infrastructure and institutions and so on. But all of these costs or management costs, we can think of these as basically being costs of trust. And they're costs that occur whenever you need to verify that some other information is true, whether that's information about who is the counterparty, or whether it's information about who has ownership rights over things, or whether it's verifying that someone claiming to be able to, or making a promise to do something in a contract has actually done that thing. So large amounts of an economy are really just administrative infrastructure to verify that that ownership is what it says it is, that that promises made have been verified, that people have that payments claimed have been made, and so on. So the work that we've done in my team, we've estimated these costs of trust to be about a third of the economy. And the significance of new blockchain technologies is that it dramatically lowers these costs of trust. So that's the significance of blockchain technologies into an economy, is huge reduction in these types of digital costs. Right, next slide, please. So let me give you some examples of this. So the first versions of the internet in the 1980s and so on were really just the internet as a communications technology. And the main thing we got out of that was email and browsers. So early internet was communication. The next generation of the internet, sometimes called Web 2, is the one that we associate with things like Facebook and Twitter and Amazon and Netflix and Uber and all of this sort of large platform corporations that are providing the economic infrastructure around payments and delivery of a digital economy. But they are corporations, and they are often very, very huge corporations. And we think of that as the commercial internet. And that's the bit we're coming toward the end of, is this period of large commercial organizations as the devices and institutions that we're using for payments and verification and all of the costs of trust associated with digital business. So the area we're entering into now, Web3, blockchain, this new sort of supercluster of digital technologies, is taking all of that economic infrastructure and moving it natively onto the internet. So when we have digital money, that's cryptocurrencies. When we have digital assets, that's NFTs or tokens or other types of digital objects. Digital identity and digital registries, blockchain. Digital credentials, tokens and NFTs. Digital contracts or smart contracts. Digital intellectual property, NFTs. Digital services, decentralized applications. Digital marketplaces, DEXs or automatic market makers, and other protocols that enable us just to interact with in a direct way without going via banks. Digital organizations, decentralized autonomous organizations or DAOs. Digital finance is what's called DeFi, and digital governance is what we mean by using token governance or DAOs or crypto foundations. So what I want to emphasize here is that we're moving into a world with Web3, or this sort of second digital revolution, where all of the base layer economic infrastructure, money, registries, ownership, identity, payments, protocols, intellectual property, services, marketplaces, organizations, even finance and government, all of that becomes digitally native. It's not provided by governments or banks or organizations. It's provided by software. It's digitally native. Now, we are at the very, very early stages of this revolution, but this is what we mean by a digital economy. It's when we've got digital economic infrastructure all the way down. All of the administration and record keeping and infrastructure that is in law and other ways of providing of verifying transactions in an economy is fully digital all the way down. So that's the transition we're going into now. We're still at the very early stages of this. This will be another decade or more at least building this out. But it's on top of this that the other digital technologies, quantum, machine learning and AI, Internet of Things, the rest of the digital tech stack builds on top of this base layer of economic infrastructure. So again, just think of that notion of a digital economy as being a full digital stack that has economic infrastructure at the base and then services and apps at the top, but it's digital all the way down. That's the nature of a digital economy transition from an industrial economy. All right, next slide, please. All right, so that's the vision I want to present in terms of the type of economic revolution we are going through now. That's taking place globally. It is happening in Malaysia just as much as it is happening in Australia, but it's massively disruptive. And it's one of the key things that it's going to disrupt is business and entrepreneurship. So I want to just give you some high-level ideas about what that looks like. So the first thing this looks like is just, first, we tokenize everything. We tokenize people with digital identities. We tokenize all of the things with digital registries and NFTs. We tokenize all of the money, which is cryptocurrencies. We go through and we take everything that exists in an economy and we build digital representations of that and put those on blockchains. That's step one. And we're maybe a tenth of the way through that process. We're still very, very early in that process. But what that looks like, the change that brings, is that this is a new type of global capitalism, digital capitalism. But instead of having it written to government registries, it writes to blockchains with the basic institutional facts. Governments are still important in this story, regulating and governing this, but they're not running the underlying economic infrastructure. That has been made fully digital. All right, what does this look like? First of all, markets become a lot bigger because they can. The costs of market creation and using markets significantly falls because more and more of the economy becomes computable. I can search and find things a lot easier. I can make payments at a global scale. I can verify ownership. So just markets will work faster, they become bigger, they become more pervasive. So this is an expansion of the markets because of this digital economic registries. Second effect, firms become smaller. We don't need firms to be as big as they have previously been, because much of the work that firms were doing around providing counterparty assurance is being done by the protocols. So what this looks like is a larger number of smaller firms, far more specialized, with more and more work being done by protocols. So markets get bigger, firms get smaller. That means competition works better. So broadly, what that looks like is a more competitive, more innovative global economy with less sort of monopoly power and less significance of large firms, and therefore the need to regulate them and control them and have and worry about the political influence of large firms. So that's a pattern prediction about how we will see these types of technologies working. Another point I would make is that the commons, as in common pool resources, works a lot better in a digital economy, just simply because it can. The cost of pushing a lot more assets and a lot more things of value can exist in digital form, which means instead of being privately owned, they can be owned by communities or in the commons. This is particularly true of data. So as more and more as data resources grow in significance, we can start to make use of the commons as a way of providing collective economic ownership. So what that looks like is, instead of public goods increasing in size, common pool resources will increase as a way in economy. So markets get bigger, firms get smaller, the commons gets larger, governments get smaller. We also will start to see shifts in the way finance works. So we've got new models of venture finance where, instead of having debt-based finance or equity-based finance, debt-based finance being loans, equity-based finance being joint ownership, we'll start to see community ownership of creating new types of projects. So tokenization of projects provides a new model of financing new projects that is neither debt nor equity, but rather a sort of a hybrid concept of dequity, if you will. So a digital economy is a different type of capitalism that emphasizes different institutions. Markets are bigger, firms are smaller, commons work better, governments are needed less because there's less for them to do, and the way in which finance works will shift as well. So all of that. The other point to note here is that we have a different type or new types of business infrastructure where protocols or toolkits are a far more important part of business infrastructure. So we're starting to see those rise in significance. And again, these protocols and toolkits are not necessarily owned by companies. They're either governed by or supported and serviced by governments, or they're privately provided. So the rise of protocols is important here. The other thing is that a digital economy, new types of projects and businesses and so on, are born digital and born global. They don't begin in the physical world in a country. They can begin directly on the internet at global scale, which has important implications for entrepreneurship because of how fast things can move. Right, next slide, please. All right, so as a theory of digital technologies, the two things we need to focus on is digital technologies. We can think of digital as a lingua franca. A lingua franca means is a term that refers to something that can translate between anything. And digital technologies are a type of lingua franca in the sense that anything digital can talk to anything else digital. So the significance of digital technologies as opposed to industrial technologies is that anything that is natively digital can, in principle, be connected to anything else that is natively digital, which enables us to join everything together. Another way of thinking about that is to call these general dimensional technologies instead of general purpose technologies. And a general dimensional technology is a way of saying that any new technology that is natively digital can connect to anything else that is natively digital, which means that it can be adopted very, very quickly, and it can scale globally. So that fundamental difference between industrial technologies and digital technologies is that the basic difference with a digital economy and digital technologies is that they can grow very, very fast, just simply because they can connect to everything. They can connect to all other parts of it. So we want to think about these. The key aspect of digital innovation and new digital technologies is this ability to connect very rapidly to all things. All right, if we can, next slide, please. So what I want to do now is to bring this back to the theory of entrepreneurship. And the way in which we understand entrepreneurship in economics. We've had several models of entrepreneurship in the past. One of the most famous and widely known ones is the Schumpeterian entrepreneur, after Joseph Schumpeter. And this is the idea of the entrepreneur as a disruptive innovator, as someone who has a new idea, creates a new business, that new business disrupts industries, and that process of entrepreneurial-led industrial disruption is the modern idea of innovation, of entrepreneurship. And we think of venture capital studios such as A16Z, or incubators or accelerators such as Y Combinator, are really models of the industrial model of entrepreneurship, where an entrepreneur starts a company and disrupts an industry. All right. Another model of entrepreneurship is what's called the Kersnerian model. This is the Austrian model, after an economist called Israel Kirzner. But this is the idea of the entrepreneur operating in markets who's alert to opportunities between that are observed in prices, where they can buy cheap and sell high, or can see an opportunity for arbitrage. So the Schumpeterian entrepreneur is someone who starts a firm. The Kersnerian entrepreneur is someone who operates in markets looking for opportunities. In a digital economy, we have a new type of entrepreneurship. And I want to give this the name a Satoshi entrepreneur. But what the Satoshi entrepreneur is doing is they're using these new digital tools, whether it's blockchain or AI or Internet of Things or other aspects of machine learning or a metaverse. But they're using these new digital tools to design economic infrastructure, or they see opportunities in the Kersnerian sense to provide new types of economic infrastructure, whether it's a new type of marketplace or a new type of way of providing ways of creating a platform for people to trade or interact and so on. So Web3 or digital entrepreneurship is fundamentally more about creating new types of economic infrastructure rather than just seeing an arbitrage trade to make or a new firm to create. And again, we're at the very early stages of the emergence of this new type of entrepreneurship. And in many ways, it's a combination of all of these. But the idea I want to emphasize here is that this new type of entrepreneurship is fundamentally infrastructure or the provision of new types of institutions through these digital tools. And this goes back to the discussion I had at the beginning of this talk, which was thinking about a digital economy is fundamentally an institutional tech stack all the way down. What entrepreneurship looks like in a digital economy is creating these new types of economic institutions and infrastructures. So that's the new way of thinking about entrepreneurship in a digital economy. So if we can move to the next slide, please. So what is this? So the future of entrepreneurship. It's entrepreneurship that is seeking to create value by lowering the costs of economic activity. It is fundamentally a way of where the entrepreneur uses these new digital tools, blockchains, crypto, AI, machine learning, metaverse, to design new economic infrastructure in a digitally native environment that enables a rapid expansion of economic opportunities for trade, for infrastructure, and so on. And that which goes to this point I was making before about digital technologies being a lingua franca or dramatically increasing the scale and speed at which entrepreneurship can work. So what we have then is a new type of entrepreneurship that is operating to lower the costs, but instead of lowering the costs of things, which is what industrial entrepreneurship is, it's lowering the costs of transactions. So it's a better, faster, cheaper thing. But instead of better, faster, cheaper in the industrial economy model, which meant better, faster, cheaper commodities, this is better, faster, cheaper transactions, or better, faster, cheaper institutions, or protocols, or infrastructure. And that is the nature of entrepreneurship in a digital economy right now, is that we're seeing lots of new Web3 companies starting up. These new Web3 companies are doing things like providing a new type of smart contract platform, or a new type of money, or a new type of verification of identity. They're providing new types of economic institutions that work at global scale to enable new types of transactions. So this is my presentation of what the future of entrepreneurship is in our Web3 economy, is that it looks different to industrial entrepreneurship, which was largely about producing new types of things, to this is Web3 innovation and entrepreneurship, and is about producing new types of economic infrastructure. So next slide, please. So what does that look like for a business school? So what I want to suggest is two things. The first is that if we take that idea of the future of entrepreneurship in a digital economy and ask, what does this mean in a business school context? It means that instead of doing economics and finance and marketing and law as separate subjects, what we have is a business school organized around a project where a student will come in, or industry partnerships will come in and say, we want to do this. We have an idea for a new thing. And then what the business school, an entrepreneurial business school will do, and when it's teaching business entrepreneurship education, is it will then provide the tools for entrepreneurial teams to build those projects. Now, the model for that is things like Y Combinator or A16Z type venture capital studios. But built into a university context, what that looks like is university business school education, providing students with these new tools to build, to create and use these new types of digital economic institutions, and to use those for developing projects. So that's how we've been doing this at RMIT. And I'll talk about that in conclusion. But the key idea here is that a new type of digital business school is built and designed around the idea that we're entering into a digital economy where entrepreneurship is fundamentally and largely based around building economic infrastructure and designing economies, as opposed to providing new types of industrial commodities and projects. So next slide, please. All right, so look, I want to round this out in terms of what this looks like for policy, just to help you sort of think about this. So one of the obvious things is that, as I said, a digital economy, markets grow, firms become smaller, there's more competition, this works better at a global scale, there's more tools and there's more business tools for entrepreneurs to use, finance is easier to access through tokens. All of that means is that a digital economy is far more competitive at global scale than an industrial economy, and it's naturally more competitive. And what that looks like then is that the role of competition policy or antitrust policy in the US is much less important, because we don't need to try and monitor and regulate and control monopolies, because monopolies just are simply much less likely to exist in the first place. However, there is a far more important role for government here in terms of dealing with the digital divide and providing digital economic infrastructure and providing particularly digital education. And this is also the role of universities. So the fundamental competitive barrier is in providing largely economic literacy, digital literacy, tech literacy, and ensuring that the basic digital communications infrastructure is open, of global quality and available to all. So there is a fundamentally important role for government here in providing that base layer communications infrastructure and education to that. When we look at innovation policy also shifts. Innovation policy is traditionally based around industry policy, where you have public support for tech development in particular sectors. So tech development in health, or tech development in tourism, or tech development in agriculture. In a digital economy, that makes a lot less sense because industries don't really exist anymore. Instead, you've just got layers of capabilities that build up and down. And instead, what is emerging is private economic infrastructure to be supported. So largely the role of innovation policy shifts around enabling that type of new competitive private infrastructure to emerge. And the other crucial thing, surprisingly and interestingly, is that intellectual property is less significant in a digital economy, just simply because there are digitally native ways of recording property. So NFTs are the obvious thing around this, but you start to have a shift that innovation policy also looks different in a digital economy compared to an industrial economy. So what we'll see then is that in a digital economy, a lot of policy frameworks around competition policy and innovation policy, as well as communications and education policy, start to shift in some interesting directions that usually all go in the direction of greater support of private and protocol-based infrastructure, but instead providing the main need for government is largely around education and communications and digital infrastructure provision. Right, if we can move to the final slide, please. So the last thing I'd like to just conclude with is in my university, RMIT University in Melbourne, we've recently developed a new type of digital business school we call Digital 3. You can, if you follow the QR code there, it'll take you to it, which is a way of integrating exactly what I've been talking about here and what I was thrilled to see that you're all doing at UMK. And what that idea is that we've gathered together the tech stack of cybersecurity and cloud and AI and machine learning and blockchain and put it into a single digital business school that is focused around providing education around this sort of project-based infrastructure. So if you want to see what this looks like, you can check out RMIT Digital 3 as an example of this. But I was very, very excited to see the incredible work that you're actually doing at UMK in developing new types of digital business schools. So with that, I will close and conclude and open up for any questions we might have time for. Thank you.
Thank you for the beneficial and valuable sharing information from you, Prof. So as we are running out of time now, so I think I can read out only one or two questions for you. So perhaps you can share for the short answer. Okay, we have a questions from Ahmad Ridwan Abdullah. He wants to know that we know that we have to embrace the digital economy and all the technologies that come with it. What would you suggest for us as an academic in a social science field to be actively involved in this development?
Yeah, thank you. Look, I think the obvious thing is to pick a particular area of development, such as in agriculture or tourism, and look at all of the ways in which you can start to create new types of entrepreneurship in that space and solution to these things. So the key idea for us is not to have digital silos where you do blockchain and AI or machine learning or other things as separate things, but to find ways to integrate them to solve actual development and economic growth challenges.
Okay, Prof. So the next question, maybe I can read from Nur Izzati Muhammad Anwar. Okay, do you suggest business school to adopt tools that facilitate interdisciplinary projects?
Yes, absolutely. And I mean, this is one of the great things about online education in particular, is that it is naturally built for this type of collaboration. So more and more what we've been finding at RMIT is that a lot of entrepreneurship projects are naturally team projects where a group of people, 2 or 3 students, will come together to work together on developing a single project. So the more opportunity you have to build teams that bring together different skills from different from different sciences and engineering components into single projects, I think that really is the future of entrepreneurial education.
Thank you so much, Prof. So before we end our session, do you have any last word from you? Maybe for 1 or 2 minutes.
No, look, thank you all for inviting me, and please do follow up on email. I put my email at the side of the slides. If you have further questions, I'm very, very happy to discuss this through email or on Twitter or other sort of social media. So do please reach out to me if you have further questions, and I'd love to hear from you. Thank you.
Okay, to the audience, like what displayed on the slide now, here is the email address of Jason, Prof. Jason. So jason.potts at rmit.edu.au. So should you have any need more explanation or more information from him, you can reach him through his email address. Okay, so I would like to thank all of you again, and especially to our speaker, Prof. Jason, for his excellent thought. I believe without all of your input, idea, and also discussion, this session would not have been success. With that, I end the session. Thank you so much.
Thank you, Dr. Alina and Prof. Jason, for the great sharing session just now. Ladies and gentlemen, this morning ceremony has now come to an end. On behalf of the committee, I would like to extend my utmost appreciation to our guests of honor. I would also like to take this opportunity to extend my appreciation to the individuals who have been involved in making this virtual conference a success. Most importantly, on behalf of University Malaysia Kelantan, I wish the participants of INSEP 2022 a meaningful and productive day ahead. I would also like to remind all the participants that we will have a prize-giving ceremony. Hence, I want to invite all the participants to be at the closing and award ceremony at 11:45 a.m. today. We will continue this virtual conference with parallel session via Zoom at 10 a.m. Kindly refer to the INSET website or your email for the details of the presentation link for each session. With that, I end our ceremony this morning with wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.